Bismillahirrahmanirrahim.
Bismillah, assalamu alaikum wa rahmatullahi wa barakatuh, everyone. Bismillah, alhamdulillah, wa salatu wa salam ala rasulillah wa ala alihi wa sahbihi wa man wala. Subhanaka la ilma lana illa ma 'allamtana innaka antal alimul hakim. Jazakallah khair for coming. Alhamdulillah, this is our first but not last family event, and we'll be having rotating subjects, inshallah. So different subjects, we'll be covering different portions. If the sisters, you guys want to come on this side, you guys are welcome to come on this side. So if one side you want to kick the guys, the sisters, so they can see up here, and then the guys can go on that side, inshallah. So the first is a very interesting topic for some of us. Some other people may just be bored, but that's fine. We're not gonna close it. Hopefully, maybe if those who are not too interested in this topic, they will become more interested. So today I have my dear brother, Al-Ustad Ahmed Reda, Hafidhahumullahu ta'ala. This is his specialty, something is a hobby, I would say, of his. So we're very, very honored to have him here with us today and talk about this. I'm here just for more support, to be honest. I'm here to learn more than I am to talk. But he knows way more about this than I do. And hopefully, inshallah, after this, we'll have a portion where we can go outside when it gets a little darker and look at it. But with that, I'll give it to our dear brother.
Jazakallah khairan. No, it's good to have you here to keep me straight, because I'll be referencing the Quran in some of the slides and so on. But pretty much the reason I wanted to have this talk is we tend to forget about our history, and we tend to forget about the sciences and the different areas that we excelled in as Muslims. And the most important thing we tend to forget about is the darkness that people were living in before Islam, and how Islam sort of like removed all that darkness and put it aside and brought people literally into the light. And astronomy is one of those areas for humanity in general, collectively. So I'll start by talking, given a little bit, in the first part of the presentation is talking about pre-Islamic astronomy, which was effectively astrology at that point. There was a lot of myths, there was superstition, there was a lot of stories, and how Islam fought that and converted that. But then with the onset of Islam and its spread, what happened after that, the second section is talking about the Muslims learning from other civilizations, expanding on what other civilizations did, and the major contributions of Muslims. And then I got some examples of some of the scientific research that Muslims did that for its time was considered revolutionary and very advanced compared to even what we do today. So to start, we gotta understand, pre-Islamic Arabia was one of the, and it still is, or Arabia is one of the oldest regions in the world that are inhabited by people. And to put things in perspective, there is hominid remains going back between 200,000 BC and 500,000 years in the past. So, for almost, at least 200,000, if not 500,000 years, humans have lived in this area. Now, you look at other regions of the planet like North and South America, human remains only go back 10,000 years and stuff like that, so they're fairly recent. And if you want to look at human history in general, humans were hunters and gatherers until about 10,000 years ago. They started settling in the Fertile Crescent, which is, in the northern part of that present day, between Syria, Turkey, and Iraq. People started settling there, and there you have agriculture, and you start to see the beginning of sedentary society. But until that point, everywhere around the planet, people were hunters and gatherers, just moving from point A to point B, and weren't really settling. But that part of the world is one of the oldest parts in the world where humans have actually lived, and there is plenty of evidence from the tools that they left over there. And they can find actually Homo sapiens remains dating back to 180,000 years ago. So there is a fair amount of rich history in that region. In addition to that, the archaeological finds, actually, there is a hadith that before the Day of Judgment, the Arabian Peninsula will become again murujan wa nahara, meaning rivers and fertile land. Nowadays, from archaeology, and it's interesting that the hadith says, it doesn't say it will become, the hadith says it will return to being like that. And archaeological data shows that it was. Now we know that it was historically back in the day a very fertile land, pretty much forested or a jungle, and then it had multiple rivers. And subhanAllah, that's part of the wahi. How would, if the Prophet ﷺ didn't have wahi, how would he know that the Arabian Peninsula was like that millions of years ago? So when you're looking at pre-Islamic Arabia, this was the crossroads. In addition to being one of the oldest areas that humans have lived, this was the crossroads for people migrations between Africa, Asia, and Europe. And the entire peninsula was dominated by Semites and Semitic languages. So whether you have Aramaic in the northwest in Bilad al-Sham, for example, or even Hebrew spoken later, or even Arabic, or different, versions of ancient Arabic, which is more related to East African languages. All of them were variations of Semitic languages. So the Arabs inhabited that region from the very earliest of times, and they were in a central location between the different civilizations. They were to the east of them, they had the Persian Empire. To the west, northwest of them, they had the Roman Empire. But even before that, the Arabs go even before the Roman and the Persian Empire, and they had interchanges with predecessor civilizations like the Canaanites and the Phoenicians and so on. And you can see that the northern Arabs and the southern Arabs, so the Arabs who lived in Bilad al-Sham, present-day Syria, Lebanon, Palestine, and Jordan, adopted a sedentary life where they settled down, and they had agriculture, they had trade, they had manufacturing, tools and stuff like that, and they interacted with their surrounding and were influenced by that. Same thing for Yemeni Arabs in the south, also had a sedentary life. And examples of those, in the north you have the Palmyrans and you have the Nabateans and so on. Those were Arab tribes, and you have some of the civilizations are very close to Arabs genetically, like the Phoenicians and the Canaanites who lived in that region. Now in that life and in that interaction, you'll see that the astrology of those groups of Arabs was heavily influenced by the civilizations they came in interaction with. So to rewind back a little bit, what we understand about people's perspective of the sky is that humans from the earliest of times recognize that the first changing thing in the night sky is the moon, right? Night after night, that's the first thing everybody notices right away. The moon changes. And it became easy for people to count days by the moon, and you'll see that ancient books will say, the first quarter of the moon, or the second quarter of the moon, or the first half of the moon, or later half of the moon. So people use the moon to calculate time. And by the way, that's why we have 7-day weeks, by the way, because the moon cycle can be divided by 7, and that's how humans adopted that. So humans noticed that. The other thing they noticed is that looking at the sky, the pattern of the stars themselves, they repeat every night, but they shift throughout the year. And they notice some stars, some patterns you can actually see in the wintertime, some patterns you can see in the summertime. So they started to relate seasons to those constellations. And they called them, like Arabs used to call them, nujum, or stars, in English. And then you had the moving stars, which are the stars that didn't maintain the consistent pattern and move between the patterns. And in Arabic, they called them nujum as-sayyara. In other words, in English, it was like, moving stars, meaning planets. They separated those. And so people recognized that, and then they started actually identifying the patterns, the associated stories, and somehow at some point those stories got included into the pagan beliefs of the time, and you'll see that in the Sumerian and the Babylonian, and the Arabs were no exception to mixing, the sky and astrology, because it's something distant, to religion itself. So while the northern and southern Arabs got to see that heavy influence by the civilizations, the central Arabs being nomadic, so in present day like central Saudi Arabia, in Hijaz, in Najd and so on, those guys were isolated from the rest. So you'll see that the influence was very limited in their in their adoption of other people's theology. Now, that doesn't mean that they haven't adopted theology. They have. In astrology, they have, but it was more limited than the Arabs who lived in like Syria or those who lived in Yemen and interacted more with more cultures. So, rewinding back a little bit, astronomy for people back at a time served multiple purposes. Whether you were Arab, you lived in Europe, you lived out in the middle of, you lived in Asia, it didn't matter. It mattered to you because it was the way to understand time, whether it's the moon cycle, the constellation cycles tells you seasons, and then it was the way to navigate. It was before GPS, the way you knew east from south and, or east from west and south from north. When you're going to go to trade, which way, how do you know, like the Arabs before Islam, they're going in the summer to Syria. How do they know that they're walking in the middle of the desert for a month, that they're actually going to hit that exact city? It was the stars that guided them. Same thing if they're going to Yemen. And the Arabs played a key role connecting the Silk Route between the Persian Empire, especially in the north, and the Roman Empire, and also to the south through Mecca. They connected the Silk Road into Africa through Abyssinia and the rest of Africa. So astronomy was key. As you're navigating the desert, you have no landmarks, many times no cities, no towns, nothing. Everything is moving. The only thing that's fixed that you can rely on is the stars. So the pre-Islamic, Arab who navigated and traveler was very skilled at navigating the sky. And you'll find that in the Quran, Allah references رحلتي الشتاء والصيف, the journey of the winter and the journey of the summer. So in the summer, the Arabs would go north to trade with Bilad al-Sham, with the Roman Empire, and products from the Persian Empire too. And then in the winter, they will go south to Yemen, carrying those goods well into Africa. And they moved different kinds of goods, including spices that came as far as India, all the way to Africa, and they moved, leather and other items from Africa all the way to the Persian and Roman Empire, to Constantinople at the time. But the interesting thing is that in general, the Arabs in Hijaz, for example, they maintain, okay, we're going to trade the goods, but we're not going to adopt much of the culture. So they already adopted enough, and we'll talk about that, that damaged their culture from the religion of Ibrahim. So a key aspect of astronomy, everybody has heard of constellations, right? And constellations are grouping of stars that people have identified, and they sort of gave them a shape. So you probably heard the word, Ursa Major, the Big Dipper, right? The Big Bear, or Ursa Minor, or Orion the Hunter. People started relating shapes in the sky because it makes it easy. Oh, what pattern of stars? Oh, the one that looks like the hunter. And people connect the dots and make sense to them. The Arabs had a similar thing, except it wasn't the same set of constellations. They had something called NWICC. And NWICC for them were groupings of stars that had a purpose in navigation, but also had a purpose in superstition and theology. And we'll cover that in a little bit. So we talked about navigation, we talked about timekeeping, and then the religious purpose and superstition, and we'll give some examples of what that purpose was. So an example of al-Anwa is al-Thuraya, right, the Pleiades, and al-Dibran. And by the way, we'll get into, but 90% of the star names are Arabic, and we'll get into how did that come to be. Until today, 90% of the star names are Arabic, because the Greeks didn't actually name most of the stars. They named a couple of them. The planet names come from the Greco-Roman culture, but they even have roots back into Babylonian and Sumerian names. The constellation definitions go back to Babylonian and Sumerian before even Greco-Roman. They just added their names to them. But nobody actually no civilization took an active role in naming the stars and mapping out the stars as the Muslims did later. And they named the stars, and that's how we ended up with 90% of the stars having Arabic names. So Thuraya or the Pleiades, as an example, I'm pretty sure, if you look in the winter sky, they're very noticeable. It's a group of stars. As you can see here, they're blue. They're young stars, about 100 million years in age. And they show to the right of Orion, and between Orion and Taurus, the constellation of Taurus, the bull. And the Arabs looked at the Pleiades as, hey, this is actually a good omen. If it were to rain when the Pleiades were rising, that means to them, to a tribe, oh, this brings wealth. But if the Pleiades if it were to rain later, but the Pleiades weren't showing in the sky and you could only see the run, you see how close they are, and they're going to move throughout the night. If the Pleiades disappears and it rains, then it's a bad omen. That was part of their superstition. And even that in the hadith, and I'll narrate it in Arabic and then I'll translate it, but the hadith says, عن زيد بن خالد الجهني رضي الله عنه قال صلى رسول الله صلى الله عليه وسلم صلاة الصبح بالحديبية على إثر سماء كانت من الليلة فلما انصرف أقبل على الناس فقال هل تدرون ما قال ربكم قالوا الله ورسوله أعلم قال أصبح من عبادي مؤمن بي وكافر فأما من قال مطرنا بفضل الله ورحمته فذلك مؤمن بي وكافر بالكواكب وأما من قال مطرنا بنوء كذا وكذا فذلك كافر بي ومؤمن بالكواكب رواه البخاري ومسلم. So a translation of the hadith that Zayd ibn Khalid al-Juhani said that in the morning, everybody knows the story of Hudaybiyah, right? So after the bay'ah and so on, and they went to sleep, and in the morning, they were, praying Fajr, and it rained. And then the Prophet ﷺ told them, you know what Allah told me? Allah told me that some of my servants, some of ibadi, woke up, some believing in me and some disbelieving in me. Those who said that the rain came from Allah and His mercy, those and is a believer in me and a disbeliever in astrology. Because people used to use astrology, and we talked about NWICC and so on, to fortune tell. So that person is disbelieving in that. On the other hand, the one who said, we got the rain because we had the NWICC, and in this case, actually, it was the Thuraya, right? It was the Pleiades. Somebody saw the Pleiades around Fajr when it was raining. And again, that person was Muslim, and he said, oh yeah, it's a good omen. It's a good omen. We can see the Pleiades and it's raining. And the Prophet ﷺ saying, this person, whoever says that, is kafir in the eyes of Allah. From Allah's perspective, that person is kafir and believes in astrology. So you can see right away, the impact on the culture from this example, what the Arabs used to believe and how it reflected, and the Prophet ﷺ had to work on the people to change their mindset. It's not easy bringing people from that perspective into recognizing that none of that stuff means much. So the key thing about actually, from a functional standpoint, the Pleiades and the Dibran, is that if it is rising in the east after sunset, that means winter is about to start. And for them, winter is about to start. It's time for the north journey to go to Bilad al-Sham, to Syria for trade. But if it's setting around sunrise, that means that summer is about to start. So now it's the time to take the journey and go south towards Yemen for trade. So from that perspective, Arabs, even after Islam, continued to use that for navigation. Understanding the sky and using it for navigation is a useful thing. It's the superstition that Islam wanted to abandon. Another example of that is another, one key star is Ash-Shara and Suhail. So Ash-Shara, there is Ash-Shara al-Yamaniya and there is Ash-Shara al-Shamiyya. And Ash-Shara was a key star, it's Sirius, and then Ash-Shara al-Shamiyya is Procyon. They were key, those two stars were important for them because that was the star you followed. Ash-Shara al-Yamaniya was a key one. You followed when you go south towards Yemen. And then Ash-Shara al-Shamiya, you followed when you go north towards Bilad al-Sham. You navigate at night and just make sure that you're always headed towards that star. That was a key. Now, Sirius is the star. It's about 8 light years away. After, you got the sun, the moon, the planets. Those are the brightest objects in our sky. But then Sirius is the brightest star in our sky. And a lot of people mistake it for planets. A lot of people, when you see it, you wonder what's wrong, why is it so bright? Because it's pretty close and it's a big star. Now, the Arabs, not only did they use it for travel, they also worshipped it. They thought that it brought wealth. This star was also worshipped by the ancient Egyptians because they perceived it as the star that brought the inundation, so wealth, fertility, and so on. The Arabs didn't have agriculture, so to them it was the wealth of trade and so on. So that was part of it, that they worshipped it, and they looked at it. They looked at it as a good omen when the moment it starts rising in the sky. The other star is Suhail Canopus. In Canopus, it rises around in the sky around the start of winter time. But to the Arabs, that was a bad omen, because if Canopus is going up in the sky, if they see Canopus, that means, oh, now is the time when we're going to have heavy rain, and in Mecca, specifically in the valley, they get flooding. So their superstition was like, no, that star is bad. And Islam came and tried to abandon all that stuff. A very important surah that I wanted to reference here is Surah An-Najm. At the beginning of the surah, the first ayah is وَالنَّجْمِ إِذَا هَوَى. So there is the reference. That specific reference is to the rise and set. According to the ulama, the rise and set, we talked about Al-Thuraya and Al-Dibran, those specific stars. How people that, the Prophet ﷺ is telling people, those stars, that superstition doesn't mean anything. And in the same surah, Allah subhanahu wa ta'ala says, وَأَنَّهُ هُوَ رَبُّ الشَّعْرَى. Sirius, the star, Allah is the God that created the Shara. So don't worship it as a God thinking that it brings you wealth. So I'll shift gears from stars into actually planets. And how did the Arabs perceive them? Because it also worked into their superstition. And this is where you can see some of the influence of other cultures and civilizations. Who here knows the story of Amr ibn Luhay? Okay, so the hadith, in the hadith, and I'm going to paraphrase here, that the Prophet ﷺ said that he saw Amr ibn Luhay pulling his intestines in hellfire on the Day of Judgment, because he's the one who changed the religion of the Arabs. So the Arabs, after Prophet Ibrahim, Prophet Ismail, were monotheistic, and it wasn't until Amr ibn al-Hayy from the tribe of Khuza'a, they took over Mecca, they pushed out Quraysh and so on, and he wanted to bring pride to Khuza'a's leadership of Mecca. And one way to do that was he started introducing gods from other cultures. So the first thing he brought, and it was from Bilad al-Sham, because it was being worshipped there, was Hubal. And Hubal signified the sun. This is the remnant of a stone statue, but back in the day, that stone statue would have golden arms, and those golden arms would shine, and people would look at it, oh yeah, it's shining like the sun. And of course, Hubal was the head of all the gods. It was, the god of, to them, divination, rain. It was, the god that brought him victory in war, and that was the god that Quraysh worshipped before Islam. And you'll see how we'll talk about how Quraysh had Hubal as their primary god, and their other tribes had other primary gods, right? Another example of that is Manat, and Manat was the moon, and Manat is mentioned in the Quran. Also in Surah An-Najm, أَفَرَأَيْتُمُ اللَّاتَ وَالْعُزَّى وَمَنَاةَ الثَّالِثَةَ الْأُخْرَى. Have you seen Al-Lat and Al-Uzza and their third Manat? And by the way, in this picture, you have Al-Lat and Al-Uzza and Manat. Manat is the one in the middle. I don't know which one is Al-Lat and Al-Uzza. They're on the side. They're the two sisters. Okay? And Manat was the god of fortune, fate, time, death, and destiny. And Manat was Hubal's wife. Interestingly enough, before Islam in Medina, when it was Yathrib at the time, Al-Aws and Al-Khazraj used to worship Manat. That was their god, the one in the middle. That's what people worshiped before Islam in Medina. And then you have Al-Uzza, which is one of Manat's sister. Ghatafan, for example, the famous tribe of Ghatafan, which also participated in Ahzab, worshipped that. And it was the goddess of honor and protection for the tribe. And you have Allat on the other side, the goddess of war and peace. And Allat was Thaqif's, the tribe of Thaqif, main god. That even after Thaqif became Muslim, one of the story of them becoming Muslim, they tried to negotiate with the Prophet ﷺ saying, okay, it's going to be very hard for us to abandon Allat. Give us some time, let us worship it for 3 years, and then we'll abandon it. And the Prophet ﷺ said, no. And they said, okay, 2, 1, and then the negotiation was, okay, no, you got to destroy it. Negotiation came down, okay, we'll let it be destroyed, but you send somebody with us to destroy it. And the Prophet ﷺ sent Abu Sufyan ibn Harb, and he sent, the other person was from Thaqif, not Urwa ibn Mas'ud, his nephew. Okay, I'll remember it in a little bit. He's a famous Sahabi. He was the bodyguard of the Prophet ﷺ in Sulh al-Hudaybiyah. So yeah, but yeah, they ended up destroying Allat after Thaqif became Muslim. I think that was in the 9th or 10th year of the Hijrah. And then And yeah, Manat was the moon, Allat and Uzza were both of them were associated with Venus. Back in the day, you could, until today, you can actually see Venus. It either shows up in the morning or in the evening, depending on the time of the year. People didn't recognize at that time that that's the same planet, that's the same object. They used to think it was two different things. So they had the name the morning star for it and the evening star. And for although people knew that, they could never show up at the same time. They never actually connected the dots that this is the same object. But so yeah, Allat and Uzza were, the Venus when it shows up in the morning and Venus when it shows up in the evening. Another god that the Arabs worship and associated with the planets was Dhushara. And Dhushara is interesting because in the Arabian Peninsula, you'll find that Dhushara was associated more with Mercury, but the Arabs in Bilad al-Sham, specifically Al-Ambalt and others, Nabateans, associated him with Jupiter. And you can see there the Roman influence, because not only did they associate him with Jupiter, they associated him with Zeus and what the Romans used to perceive of Zeus. Same for the Palmyrians and the other Arabs who lived in the north. But the Arabs who lived in the south associated him more with Mercury and didn't have that Zeus-Roman connection. So, as you can see, the stars, the objects in the sky were important for functional purposes like navigation, time, and other things, but then you had a big theological aspect that they associated it with their gods, with superstition, and so on. And Islam came at superstition really hard, cutting it out, saying, nope, this is not acceptable. An example of that is eclipses and comets were considered back in the day a sign from the gods. Whenever people would see a comet or see an eclipse, to them that was a sign of the gods, and you'd have whatever you want to call the priest of the gods, at the Kaaba or whatever, would stand next to the idol and say, oh yeah, the sun was eclipsed because the gods are happy or sad, whatever the story he wants to make up at the time. There's no consistency. It was just whatever fit him, they went with that narrative. And same thing with comets. And of course, with the abandonment of idol worshipping and so on, still some jahiliyyah stayed with some people that after Prophet Muhammad's son Ibrahim passed away, as they were burying him, a solar eclipse happened at that moment. And some people came out and said the sun was eclipsed because the sun was sad for the Prophet's son's death. Okay? So you see how Jahiliyyah, although they're Muslim, how Jahiliyyah is still there amongst some people in their thought process and the superstition. Yeah, it's an eclipse, of course. Yeah, the sun is sad because the Prophet ﷺ's son passed away. So the Prophet ﷺ gathered the Sahaba, and the hadith says that إن الشمس والقمر آيتان من آيات الله عز وجل ألا وإنهما لا يكسفان لموت أحد ولا لحياته فإذا رأيتهما كذلك فافزعوا إلى المسجد ثم قام النبي صلى الله عليه وسلم فقرأ بعضا من سورة الذاريات ثم ركع ثم اعتدل ثم سجد سجدتين ثم قام فقال ففعل كما فعل في الأولى. So the hadith is that when the sun was eclipsed and the Prophet ﷺ heard that, some people are saying, okay, the sun is eclipsed for the death of the Prophet's son, Ibrahim. The Prophet told the people, he gathered the Sahaba and everybody, and he said, the sun and the moon are two ayahs from Allah subhanahu wa ta'ala. And they do not get eclipsed for someone's death or someone's birth. And if you were to see him eclipsed, go to the masjid and pray. And he went and he prayed 2 rak'ah, a description of 2 rak'ah, and then he read Surah Al-Dhariyat during that eclipse. So as you can see how Islam was trying to take out the Arabs from that superstitious astrology, based background, which by the way, unfortunately, the Europeans in general couldn't actually separate that in the Roman pagan religion, and then effectively most of that ended up making it to Christianity and the different variations of it and the different saints and all that stuff, and they couldn't separate any of that. But Islam put a hard line saying, nope, this is all going to go, this is all in the past, and took a very rationalistic approach towards the sky, which by the way for that time was unheard of, because the sky was something that was not understood. We can only see the patterns of the stars repeating every night and repeating every year, but we don't actually understand anything beyond that. So, before I shift gears to my next part, I'd like to just solicit questions, because I'm going to actually shift gears into Islamic astronomy. So this is pre-Islamic astronomy. Any questions? And we'll have questions in the end. Okay, so, yeah. We do, so interestingly enough, they back calculated, and there are records of that eclipse being visible by the Romans and being recorded, and that's how we know exactly which day in the Gregorian calendar that is. So I forgot. Yeah,
so we can translate it, right? So we can translate that based on the Gregorian calendar. We can basically translate that to the Hijri calendar and make sure that it does kind of overlap around that time, because this is after the Hijrah.
Okay, let's shift gears to Islam coming onto the stage. And by the way, before we actually get to deep dive into this, in the late 6th century, the world was, you can say, just going into deep darkness. If you read the history of that time, it was very depressing. Romans and the Persians for hundreds of years just going after each other, war after war, depleting resources, annihilating entire cities, and just destroying everything. There was no continuous trade, there was no peace, nothing. And so that's on the political front. On the scientific front, the Dark Ages have already started. Christianity has taken root and suppressed any scientific research because it considered it part of paganism and couldn't look at it objectively. If you look at it from a theological standpoint, you will see that the earlier, the earlier versions of Christianity, like the rabbinic Christianity, was gone. Any Christianity that believed that Prophet Isa was a prophet, all that stuff is gone. Now we have the records that, yeah, that stuff existed earlier. And what you had becoming dominant at that point was the Pauline Christianity. You had Arian Christianity in pockets in Bilad al-Sham, in North Africa, you have it in Spain, but the rest is Pauline Christianity, which is based on the Trinity, based on Jesus as the Son of God. That took root, that dominated, and of course the Persian Empire was pagan, fire worshipping. So there was no true faith, from a theological true belief, or a group that actually worshipped Allah properly on the planet. Politically, things were messed up. It was very dire for everybody. And then politically, economically follows that, where there were a series of plagues because of all the wars. There were a series of plagues that were sort of becoming periodic. Every 11 years there'd be a plague that annihilates X number of people. Interestingly enough, the last of the plagues occurred after the Muslim conquest of Bilad al-Sham, Ta'un Amwas, but then after that there were no plagues for a while, because war and death and all that stuff and had ended for a while. So the world was in a dire situation. You can look at it from just in general scientific, theological, political, until Islam came on the stage. And in less than 90 years, Muslims, especially at the time of the Khulafa al-Rashidun up to Uthman ibn Affan, they conquered an area for its time. It is the biggest empire that the humanity got to see. And they got to bridge from and by the way, this was the center of the civilized world. You look at it on the map and you're thinking, oh yeah, there's still the rest of the planet. This was the center of the civilized world. Europe was isolated at that time. It was technically a backwater. Nobody has heard of London. There was, or even Paris, was a small town. All these cities that we hear of today were all small towns. And the Muslims completely took over the Persian Empire, and at the same time reduced the Roman Empire to about a third, into a rump state, only controlling Anatolia, part of Greece, and a couple islands in the Mediterranean. And the Muslims took over the entire North African part of the Roman Empire, in addition to Bilad al-Sham and a significant portion of Anatolia. But so what that created is, before that you had borders between two warring parties, the Persians and the Romans, right? Now you have the center of the world, the civilized world, controlled by one entity. That opened the trade routes. You can go from Andalusia, from Spain, all the way to Central Asia and not have to worry about being kidnapped, or which side of the war you're on, or what's going on, or safety. It was a central government, and that was during Khulafa al-Rashidun, and the same time during Bani Umayyah. Despite any groups, despite their pros and cons, there was open trade for the first time. And by the way, that was historians estimate that was for the first time in 700 years, in almost a millennia, 2/3 of a millennia. Trade routes were closed, and finally they were open. Now, so you can go from China to the Atlantic, and that led to a revival of science, because now you have all these cultures with their pre-Islamic knowledge, all of them getting fused into the Muslim society as they become Muslim, and that led to a revival of science. And that revival of science took multiple stages. One of the very first earlier stages was, okay, let's start with translating the sciences of others. You got to start somewhere. And then Muslims started doing that, and then, okay, we translated books, now let's start critiquing those books, critiquing the content. And looking at the content from the perspective of, pure scientific method, and you see Hassan ibn al-Haytham developing scientific method, which is studied today. It was developed by Muslims. So you see the critiquing of text. Okay, if something checks out, then we move forward with that theory, but if it doesn't, we move away from it. And then the third step in developing science, you translate, you critique, and then you evolve, you develop your own science, which Muslims did that. And the other key factor is, you look at this large piece of land. Before Islam, that entire region spoke many different languages. But with Islam and the Quran specifically, there was one common language that not necessarily everybody spoke that language, but it became the combining language for everybody. And it became the language of science. So yeah, people in North Africa adopted Arabic, or in Andalus or in Bilad al-Sham in Iraq, but people in Persia, for example, or Central Asia, didn't adopt Arabic, but that was not a barrier for them because everybody understood Arabic at that point. And that ushered in a millennia of scientific development. An example of that is Bayt al-Hikmah, which Harun Rashid built in Baghdad. And it was built between 754 and 775. And they brought in multiple texts. Started with translations, and then critiquing, and then evolving that knowledge and expanding beyond that. And the languages of translated books in there, they went from Greek to Chinese, Sanskrit, from India, Persian, Syriac, and all that stuff being translated to Arabic. Even a lot of the key texts that Europeans rely on when they say, oh yeah, the Greek culture and all that stuff, most of those texts got translated from Greek to Arabic and then from Arabic to Latin. And the Greek version is not there anymore. But for some reason nowadays people will say, oh yeah, it came from Greek, but they will totally miss that it made it to Arabic in the middle and their translation is off of the Arabic version, but they will forget about it in their attempts to forget about Muslim contributions. So coming back to astronomy, one of the key things that Muslims in Bayt al-Hikmah and in other institutions like that, Jamiat al-Qayrawaan in Tunisia and others, they started actually, with Islam, rejecting astrology. They started drawing a barrier between, okay, what is scientific when we're looking at the sky versus what is, superstition and mythical stories. An example of that is the Almagest. I don't know how many of you have heard. So just to wrap up here, Bayt al-Hikmah quickly. Bayt al-Hikmah, unfortunately, was destroyed by the Mongol invasion of Baghdad in 1258 when Hulagu Khan destroyed Baghdad. And one of the key things that he did was he took they needed to cross the Euphrates and to continue their invasion west. Their books that they took, they burnt a lot, but they also buried the books in the Euphrates. And the books were enough to build a bridge for the army to cross. That just tells you how many thousands of manuscripts were destroyed. Until today, it's one of, in the Eastern world, everybody knows about this and recognizes how much knowledge was lost, but in the Western Hemisphere, they don't recognize it. By the way, the amount of manuscripts that were destroyed, it dwarfs, like when they talk about the burning of the Library of Alexandria and other stuff. The Library of Alexandria burning is minor compared to this when it came to what was being lost from the number of manuscripts and stuff like that. And we have a lot of books that are being referenced. We have their titles and we know who wrote them, but we don't have the text because the remaining copies were all buried in the Euphrates that day for the Mongols to cross and continue west. So I've talked about the Almagest. I'll get to it in detail, but I'll talk about one of the scientists that studied in Bayt al-Hikmah, and that scientist is Ahmed ibn Muhammad al-Firghani. And from his last name, can anybody tell where he's from? No. He lived in Egypt. Where? Italy. No, not from Europe. No. Close. Go a little bit east. You're very close. You're very close. Yeah. It's good. Yes. So there is the Valley of Fergana in between. I think it's between Tajikistan and Uzbekistan and Turkmenistan. And he hails from there. His family migrated to Egypt. He lived between 800 and 870 AD. In Egypt, and he was educated in Bayt al-Hikmah, and he wrote books on the elements of astronomy and celestial motion. So he studied the stars, he studied the planets, and he started recording their motion, and he wanted to come up with some equation for the planetary motion. So one of the key things he did was correcting the measurement for the circumference of the earth. Throughout history, you'll find that this problem, the Greeks went after it, not a lot of Romans, but a lot of Greeks went after it, and Babylonians. And then you see the Muslims going after the problem, how big is the earth, circumference-wise, as a planet? So he corrected for that, and I'll talk about what his actual measurements were. He also went to correct for what's our axial tilt from the sun. They understood the axial tilt. By the way, Islamic astronomy, while European astronomy, or Europeans, they were like flat earthers literally in the Middle Ages, Islamic astronomy was, no, we live on a sphere. That was well understood from the very beginning. That's one thing. The other interesting thing is that while Claudius Ptolemaeus, sort of mandated, well, he wasn't, the church took his idea that the earth is the center of the universe, or the center of the system that we're in. The Muslims actually had a different perspective in astronomy, and we'll talk about that the sun is actually the center of that, and you can see that from very early times. It wasn't until Copernicus in the 1600s that Europeans started scratching their heads and saying, oh, wait a minute, the Earth-centric model is wrong. So yeah, he looked at the axial tilt, and he looked at the perihelion of the sun and the moon, meaning the closest point of the sun and the moon to the Earth, and the farthest point, the perihelion and the aphelion. And by the way, there is a crater on the moon named after him for his work. So we talked about the Earth's circumference, and what Al-Firghani did is that, okay, you go around the Earth, the latitudes, you have 360 degrees, right? And his idea is, if I can measure the distance of 1 degree and then multiply it by 360, I'll get the circumference of the Earth. Simple math, right? So his idea was, okay, he picked a material. They made a leather rope, because leather with the cold, leather doesn't actually expand or contract much once you turn it into a rope. And then he at the time, he lived in Bilad al-Sham as he was studying. And then he went between Al-Raqqa in present-day Syria and Tadmur, also in Syria. And literally he had people, and they extended one big long rope. It's a long distance, by the way. And so, because he knew that based on the angle of the sun, this is 1 degree. Those 2 points, those 2 cities are 1 degree latitude away from each other. So he said, okay, if I can extend the rope between the two and then measure that rope distance, multiply it by 360, I will get the circumference of the Earth. Okay? So his estimate came to 56 2/3 of Arabic miles per degree. Okay? So for every degree, it's 56 2/3. So you multiply that by 360, and he arrived at a circumference of 40,248 kilometers. Okay? This is a measurement in the 800s. Okay? No satellite, very basic measurement. Okay? Anybody can guess what the actual is, how far off he was? So the satellite measurement is 40,068. He is off by only 180 kilometers. So you look at the science he had to put into this. He knew this based on the sun angle in Tadmur and the sun angle in Raqqa. There is a subtle difference that this is actually 1 degree. Okay, I got 2 good cities to go after. And then he picked a material that doesn't expand and measured the distance and then did this calculation. And there you go. This is not that bad. 180 kilometers or 111 miles off. He's pretty good. By the way, the interesting thing about his conclusions is that Al-Bayruni did a similar, those of you who have heard of Abu Rayhan al-Bayruni, who lived in Bukhara, about 1000 AD, and he deserves a presentation on his own. Al-Bayruni took these measurements, evolved them, came up with a slightly different number, but he drew a very good conclusion, which is, wait a minute, if we are looking at the entire map of Eurasia, so from the Atlantic all the way to China, and the Muslims had mapped it by then, this is only 2/5 of the Earth's circumference. So Al-Bayruni was saying, okay, we only have mapped 2/5 of the circumference of the Earth. What about the 3/5? There is 60% of the face of the Earth we know nothing about. And he he postulated that there might be a continent on the other side. And he was even in Biruni's writing saying there is probably a continent on the other side and it might have humans living on it for all we know. Now, interestingly enough, those writings of Al-Firghani and Al-Biruni is exactly what Christopher Columbus, when he went to Queen Elizabeth in 1492, he took those writings to convince her, see, people are writing about something on the other side. People are mistakenly saying, oh yeah, he went looking for India. By the way, that's not a true story. No, he actually went looking for what's on the other side, and he leveraged those writings and he referenced them. And by the way, Copernicus, in his modeling and so on, that got the Europeans to abandon the Earth-centric model into a solar-centric model, adopted the writings of Al-Firghani and Al-Biruni. And another tangent here about Al-Biruni, because he's such a rich guy when it came to his work output, is that everybody wonder why is the hour made out of 60 minutes and why a minute is made out of 60 seconds? Or who came up with that? Anybody can take a guess? Because back in the day, people had a sand clock for measuring time, and the amount of sand was the amount of time in an hour, and you're supposed to flip it around 24 times a day, or if you're keeping track of time, every hour you flip it. Or they would have candles that would burn at a certain rate, and it's effectively 1 hour for every percentage burn. But anybody know how we actually got to measure from only unit of hours? All our measurements in the past were in hours until a certain point we started to count to the base of 60 for time. Come on, I sort of gave the answer away. It was Al-Biruni who came up with that idea. He figured out how to measure seconds, figured out how to measure minutes, and he divided the hour into 60 seconds and a minute, the hour into 60 minutes, and the minute into 60 seconds. And until today, we use it. And nobody actually thinks twice where that came from. That came from the Muslims. So shifting gears now back to Al-Magas. So this is we covered here a scientist who was educated in Bayt al-Hikmah and the kind of and he moved to Egypt and the kind of work that he did. And when you compare it to the accuracy, how methodical he was and how accurate he was in his measurements for the time, this is some very good science. When they mention the Greek measurement of the circumference of the earth, specifically you'll hear about Eratosthenes, who lived in Alexandria during the time of the Ptolemies ruling Egypt. Eratosthenes' measurement is off by 20%. It's off by 10,000 kilometers. Okay, that was the most accurate, you can say, Greek calculation, off by 20%. He was far off. This is a pretty good measurement. So shifting gears to the Greeks, there's the Almagest. And the Almagest was, the book that was written by Ptolemy. It was written by Claudius Ptolemaeus, who lived in Alexandria, considered part of the Greek culture, and he lived in the 2nd century AD at the time. And it was considered the book that gathered the primary knowledge of the Greeks and the previous civilizations when it came from an astronomy standpoint. Okay? So given that it was that kind of book, and it had astronomy and it had a lot of astrology, all the stories you hear about, the mythology of the Greek sky, if anybody has heard of that, and the different gods and they're fighting together and all that stuff, and this god is, Apollo is represented by this star, these group of stars, and you have Perseus, the other god or other hero presented by those group of stars. That's the book that contained it. So it's a book that blended both science and astrology, both in mythology specifically, Greek mythology, both of them together in one book. And when it comes to, we talked about first Muslims translated and then they critiqued and then they evolved. So when it comes to translation from an astronomy standpoint, this was one of the very earliest texts that they translated. We know that there has been 4 attempts to translate it. The original book is called the Mathematica Syntaxis. By the way, in Western Hemisphere, that name is lost, and it goes by the Almagest, which, funny enough, is the name that the Arabs called it. And nowadays, a lot of people cannot actually recognize that the L comes from Arabic, and the Arabs at the time when they translated it, they called it, they called it El Majesti, and it came from the Latin word majestic, because it was such a great book. It was like, oh, this is the majestic book. So they blended Arabic and Latin when they came up with the name, and then we have the word Almagest, and the original Greek name is totally lost. I think it was in Conian Greek, which is also a lost language. It's not spoken anymore. We can translate and understand it, but it's not spoken anymore. So it's interesting how, the Greek name is lost, the Arabic name, or the name that the Arabs gave to the book, is the one that lived on. And nowadays, you talk to anybody in the Western Hemisphere who knows about astronomy, they'll know about the Almagest, but they will never actually trace that the Arabs had a touch on it. So the first and second translations of the book were about 700, 800 AD. They were during the Umayyads. Those translations were lost. And then you have a third translation by Al-Hajjaj ibn Yusuf ibn Matar, and he translated this book, and he translated Euclid's Book of the Elements, which was a chemistry book. It was a chemistry/alchemy book. Also, chemistry is another science that mixed magic, and you react this with that, you get a third element. So Hajjaj ibn Yusuf ibn Matar, he translated the book, but when he translated it, he didn't take it verbatim, word for word. He went through the book, and as he was doing the translation, he started applying common sense to what is actually mythology and what is actual science. So you'll find the translation actually into two halves. The first half is the scientific part. He didn't get rid of the mythology. He still translated and kept it in the back half, and that's how people nowadays know about Greek mythology from his translation. The original text that's in Greek is lost. There are no surviving copies. There hasn't been a surviving copy for over 1,000 years. If it wasn't for the Muslims translating this book, it would have been lost. But all that book contained were the constellations. There were no star names. There weren't a lot of details in it beyond that. And then you have the evolution after Al-Hajjaj ibn Yusuf ibn Matar. You have during the Abbasids, you have Abdurrahman al-Sufi. Abdurrahman al-Sufi, he wrote a book, the Book of the Fixed Stars, Kitab al-Nujum al-Thabita. And Abdurrahman al-Sufi, he wrote his book in 964 AD. And what he did was he took the constellations, and at that time, people were starting to study the stars and trying to categorize them. It's hard when you have 10,000 objects, identify what is what. So he started applying names to the stars, and he gave them names in Arabic. And as you can see here in the image, and I don't know if it's readable back there, like the primary star the primary star in the Big Dipper, the bear, is Dub. Dub means bear in Arabic, right? And then you look at the other organs. He pretty much adopted. Okay, this is the leg. This is the chest. There is Cygnus the swan. So you have the wings of a bird, the chest of a bird, the head of a bird, the tail of a bird, etc. And that was the methodology he used to name the stars, because his job was, okay, I'm gonna name the stars, label them, so that scientists, when they're talking about a specific star, if he says, okay, we're talking about Dub, for example, the star, everybody knows which star they're talking about. And he wrote his book, and interestingly enough, there is a 1,000-year-old surviving copy that's in the Met Museum in New York. And it's scanned, and all of it is online for people to view. And it's interesting because it's over 500 pages. The 500 pages are online. And, you look at the science that's in it. It's a lot of fun. His approach when he was putting the book together, you can see there are two drawings of the constellation. There's one drawing is if you're looking at it from inside Earth, looking outside of the sphere, right? Looking outside in the sky, this is how you would see it. But then there was another tool that people had back in the day, which was a brass ball, and then they had mapped out the major stars on that. So there's the perspective. If you're looking at the brass ball of that resembles the sky, are looking at it on the map, this is what it looks like. But if you're looking at the sky, that's what it looks like. So another interesting thing about his book is the Andromeda Galaxy, which is the closest galaxy to us, about 2.5 million light years away. He has the very first record of it. And he describes it as there is the big cloud, which is the Milky Way, and there's the small cloud, and he specified where it's at, which stars it's in between, and he's saying that the wind doesn't move it, weather doesn't impact it. This thing is way back there with the stars. And at the time, people didn't know about galaxies, but he was the first one to record and describe the Andromeda Galaxy. In addition to that, the Large Magellanic Cloud, that's also the earliest record of it, and it's only visible if you're south from here in the southern hemisphere. So this is another example. Everybody here has heard of Orion, right? Orion the Hunter, and I'll give you guys a quick quiz here. Orion the Hunter has a sword. So, and there is based on a set of stars. So the star that resembles the sword, what's the name of that star? No. Sword. What's sword in Arabic? Yes, Saif. Yeah, and I'm pointing at Sheikh Saifullah here.
Yeah, I don't know what safe means.
Yeah. So Abdurrahman al-Sufi, okay, the star that is designated as a sword, what are we going to name it, right? In the depiction, right? So he used the Greek depictions and okay, this is the sword, and then you have the leg. What is leg in Arabic? You're close. Come on. What's leg? What's the foot? No, there's another word. Close. Yeah, Rijl. So what's the name of the star? There you go. It's pretty simple. It's funny, when you read when you read star names, there is the Draco, the snake. What's the main star? Right? What's snake in Arabic? Thawban. It's pretty simple and straightforward. So he used that approach, and you'll find, for example, Lepus the rabbit. The main star is Arnab, which is rabbit in Arabic. And Abdurrahman al-Sufi, his objective was, let's have consistency, because when people are studying these stars, we want to make sure if we're talking about the star, Saif or Arnab and so on, if I'm saying this star, that book translated on, let's say I'm writing in Andalus in Spain, and then my book makes it to somebody in Central Asia, that they can actually go and tell, oh yeah, we're both talking about the same star, we're comparing the same exact object. And by the way, those names of the stars, because it was used in all these books in the early, because of the Muslims for a millennia. That's why even NASA later, when they were like, okay, how are we going to categorize stars and name them, NASA and the International Astronomical Union ended up adopting all the Muslim names for stars. And until today, yeah, they standardized the spelling in English, but it's the same word. And they would tell, yes, this comes from Arabic, and it was mentioned by Abdurrahman al-Sufi. It goes back to that guy for naming all the stars in the sky. So now when you look at the sky, you can relate to it and our Muslim culture with that. This is the Big Dipper. We've talked about it. And so any questions so far? Okay. I'm going to have more star name quizzes. If you know the word in Arabic, it's pretty easy. So, sounds good? Okay. Well, yeah. I was saying I'll have more star name. Okay. The tail of Cygnus the swan. What's the star name for that? What's the tail of an animal? What? You're close. No. It starts with a del. What?
Was
What you say? Danab.
Right?
Yeah. Yeah. Or for example, you have Vega, the eagle. The main star in it is Al-Ta'ir. In English, they say Altair. It's Ta'ir, Al-Ta'ir. So you have Abdurrahman al-Sufi, doing that, and it lived, subhanAllah, lived until 1,000 years later. If you're interested, I can send you the link to the book. You can actually, this book is in the Met Museum. It's on display. It's fully scanned, and the pictures are available online. If you can read it, if you can read the Arabic, it's over 500 pages. I flipped through it. It was very entertaining to read through it. And it also brought me a sense of pride that Abdurrahman al-Sufi lived in Persia. He didn't speak Arabic as a first language. But everything he wrote in Arabic 1,000 years ago, we can understand it if you speak Arabic, no issues at all. Contrary to in somebody who reads even Shakespeare in English, which is like 400, 500 years ago, they have a tough time understanding it, or even Victorian English and stuff like that. And that is because of the Quran. The Quran preserved the Arabic, codified it, and preserved our understanding of the different words, so that there are changes of uses in time, but not much. The core meaning is still there. So I'll shift gears here to another scientist who worked in Bayt al-Hikmah and did astronomy work, and that person is Muhammad ibn Musa al-Khwarizmi. And I'm pretty sure a lot of people have heard about him because he is the father of algorithms. He was, at his time, the head scientist at the House of Wisdom. He lived between 780 and 847. Born in Khwarizm, which is in present-day Uzbekistan. His family moved from Khwarizm into the center of the Muslim world at that time in Baghdad. And he led the House of Wisdom, whether it was scientific research or teaching, and he had a lot of scientists. For example, he had over 70 cartographers working for him, 70 people drafting maps for him, just for cartography alone. From an astronomy standpoint, there was a couple hundred people who were doing actually astronomy research for him and other stuff. So as I said, he managed the House of Wisdom, and his key contribution, he wrote a book called Kitab al-Jabr, the book of algebra. He put the basis of algebra. And the importance of that book is that before the book of algebra, before the Khwarizmi, math was simply 1 + 1 = 2. You had to have two numbers, and then there is the result of them. But then Khwarizmi introduced, well, what about having an unknown, x, the factor x? If we have an x and we solve for x. That was the first time that was introduced to mathematics. The other thing was he established rational and irrational numbers, and he also established geometric magnitudes, which were also important for astronomy. In addition to that, his was the first, because he introduced x, he established linear equation and solved it, and he established quadratic equation and solved it. This set him up to be the father of algorithms. Now, this was important for astronomy, and we'll cover how he used it in astronomy. So, a key thing in history of Muslims, there is a kind of books called Zij, and it comes from a Persian word, but it was an astronomy book that our history has over 200 of those books recorded. And as you can see here, it was a big table, and the table starts with a designation, going back to Sufi's book. Okay, there's this star, and that constellation has a designation, would be Alif or Ba or etc., right? So it will start with the designation of that star, and then it will record its motion throughout the night in that book. And Muslims started developing those tables, and their purpose was, we'll capture the data. Literally, this was pure data collection and trying to calculate the celestial positions of the stars, how they change throughout the year. And you have, these were like big, think like phone book thick books, and they would have multiple of those. And the one that Al-Khwarizmi specifically wrote was called Zij Sind Hind, and we'll explain why that is. Zij books were inspired. The Greeks didn't actually do anything like this. They attempted to do something like this, but they didn't actually collect that level of data. Interestingly enough, the ancient Indians in the Indian subcontinent had some semblance of establishing tables like these and starting to collect data around the stars beyond astrology, which were the Greeks were focused on. And there was a specific book that made it to Al-Khwarizmi and made it to the Muslims, and the Muslims translated it, and it was called the Siddhanta. And the Siddhanta was an ancient book. It's not known when it was written, but it made it to the Muslims around the time of Al-Khwarizmi from the Indian subcontinent. It was translated, and then the whole approach of let's actually create these big tables and collect as many data as we can on the positions of the stars. So also the book, in addition to positions of the stars, they also collected data on positions of the sun, the moon, and the planets, right? Because it was important to them. By the way, a lot of the studies around the moon, Muslims leveraged that to try to calculate, okay, Ramadan, Eid, all these things, so that they would figure out equations and figure out a consistent way. It goes back over 1,000 years. It goes back to the very first early centuries of Islam, of Muslims trying to develop that. And you'll even find, for example, everybody knows Ibn al-Qayyim al-Jawziyah as a faqih, for example, and student of Ibn Taymiyyah, but most people don't recognize that Ibn al-Qayyim al-Jawziyah has equations on the motion of the moon. And he was collecting his own data and trying to come up with his own model for the motion of the moon. So yeah, you had fuqaha who were also doing science because it served a purpose. So Zij Sindh Hind, what Khwarizmi did was he consolidated Almagest and the Siddhanta from a data standpoint. It was a little bit before Sufi, and then later in the later iterations, you can see all the stars that were captured in the book were related to the Sufi designations for stars in there. Now, the key thing about the measurements, Al-Khwarizmi decided to split time into cyclical periods. Before that, people didn't really think about, okay, how am I going to break down time? And he thought, okay, no, it's a cyclical period of a year, months, days, weeks, days, etc., and then hours. And then the data, all of it was captured as a function of a sine function of motion in the sky. Because you don't have the objects moving straight, they move on a curve in the sky from their rise to their set throughout the night. So his book, his Zij book, was the very first that sort of established the methodology. It was the first of many. There's 200 that followed after that. And he sort of like set the template for how to collect astronomy data. And the Muslims are the ones, until today, when we look at the sky, we look at the position of a star as going from the horizon up. So that's one angle. It's called altitude. Okay? And then there is from straight north, and you rotate. And that's called azimuth. And the word azimuth itself, the Arabs used to call it asemt. Then it got Latinized into azimuth. And that is still the consistent method until today to identify a location of stars in the sky. Now, as I said, Khwarizmi wrote the first book. Later, his book was connected with Sufi's designation of the stars. And then you see that Zij books ended up being developed all over the world, Muslim world. You'll find ones generated in Andalus, ones generated in Central Asia, in Egypt, in Bilad al-Sham, in Iraq, in Yemen. Muslims got busy generating those books, and there's over 200 full Zij books surviving until today, stretching an entire millennia. And by the way, NASA has incorporated all that data, carried it over, and they still collect that data for positions of the star and apply corrections to them to enhance their data over, more and more and more. So that knowledge didn't go to waste. Eventually it got leverage for further and further calculations. And even when you look at like Johannes Kepler, who figured out the equation of planetary motion, he leveraged those books. Or Copernicus, who leveraged specifically Biruni's book, he leveraged Al-Firghani's book, he leveraged Khwarizmi's book and his calculations to conclude, for the Europeans, because for others it was already concluded in millennia, or at least 600 years before, that the Earth orbits the sun and it's not the other way around. So you'll notice that I have one specific one here. highlighted in red, Zij al-Sultani, which was written by Ulugh Beg. And just a historical background, anybody heard of Taimur Lenk or Tamerlane in English? Okay, this is his grandson. So Taimur Lenk or Tamerlane, he came out of from the eastern parts of the Muslim world, of a Mongolo-Turkic origin, and he was a warlord. And for then, the Turkic tribes of that region just adopted Islam, and it was right after the invasion of Genghis Khan and the Mongols west has sort of like destroyed a lot of things, but also has receded. And Taimur Lenk tried to sort of like live up to the legacy of Genghis Khan. So he ended up building a big empire, and shown here in the map. His son Shahrukh, was a much better person. I have a segue here I gotta say about Taimur Lenk. It's mentioned in history books that he brought a couple of poets and told them, I like the Abbasid caliph titles, Al-Mustasim Billah, Al-Mustansir Billah, and so on, right? The titles are, the one who is victorious because of Allah, and the one who is, holding steadfast to the path of Allah. And so, these kinds of names. And so I think it's narrated in a lot of historical books, but I don't think it's true, and I'll tell you why. So the poets told him, oh yeah, we can come up with a title for you like the Abbasid caliphs. And he said, okay, tell me, what should it be? And they told him, A'udhu Billah, or Na'udhu Billah. The reason I don't think that was true, because imagine you have a guy who was a butcher, who killed people with impunity, didn't care, and you tell him your title is Na'udhu Billah from you, you're probably dead. So if it's true, whoever said it is dead, and if whoever said it is alive, probably not true, because they didn't say it. But I thought every time I read in a history book, I just chuckle. But yeah, he was a warlord, but his son tried to, his son Shahrukh tried to model himself more as the other Muslim leaders, as a patron of science. And one of the things was his son, Ulugh Beg, who also ruled the empire for a short period of time, also picked up astronomy and physics as a science that he contributed to and evolved. So Ulugh Beg was born in 1393 in Samarkand, and he was the ruler of the Timurid Empire only for 2 years because he was assassinated. But his contribution to science started even when his dad was alive. And he was skilled in math and astronomy, and specifically in observational astronomy and taking measurements, and he was really good at it. So during his father's reign, Shahrukh, he built the Ulugh Beg Observatory, which still stands until today. This is the entrance to it. And he went on, and hired a lot of astronomers. He hired Ghayath ad-Din Jamshid al-Kashi, for example, and he hired, who was the architect of the building and the first director. He hired Salah ad-Din Qadi Zaid al-Rumi. You hear about him in a lot of science books, specifically in astronomy. Mu'in ad-Din al-Kashi, al-Qushayji, and Ali al-Qushayji is important in Muslim history because this is around the time that the Muslims conquered Constantinople. It started in 1420. In 1453, 33 years after the build of this observatory, Muslims conquered Constantinople, and Muhammad al-Fatih, trying to establish, Constantinople as a capital for the Muslims and for the Ottomans at that time, he hired astronomers, and Ali al-Qushayji, who worked at this observatory, went over there and established the Constantinople observatory, which still stands until today as a nice historical site. And they had over 60 mathematicians and astronomers working in this observatory. And I'll show you pictures of the inner side of it, but the concept of it is, remember, this is before telescopes. But does anybody know how does a sextant work? Okay? So this was supposed to show one picture at a time. Okay, I'll use the laser pointer here instead. Okay, so the first thing is you have, a tube. This is before optics. Later, optics got added to it to enhance the view. But you have a tube, and you line up the sextant all the way back, and you look at an object in the sky and line it up with the horizon. Okay? Sorry, I mixed it up. First thing, you line up the sextant to the horizon. That's the first thing, so you know what your base angle is, what your level is. And then you swing the arm, the lower arm, which is also swinging your tube that you're looking through, to the object that you're looking at, right? So now you're swinging the arm, and now you have that object in sight, and what the sextant is giving you is the angle between the horizon and that object. And for astronomy, you do this upright. Now you have one position, and then you do it the other way from a reference point, and you do it to the right or to the left, depending on the way you're looking, and now you know the other position, right? Mostly you would go, your reference point would be you go from north, and then the angle from north. And then you have the other position. So using a sextant with the two mirrors, one looking at the horizon and the other one looking up above, you figure out what the angle between one object and the next. Now, one thing everybody here has learned from geometry is that a 1 degree difference at the origin is not noticeable, right? 1 degree difference between two different lines at the origin is not noticeable. But far out, the more you go out, the more noticeable it becomes because it gets amplified. So Ulugh Beg's idea was, hey, what if I make a huge sextant? Okay, this is before telescopes. This is before they can actually have precise measurements. What if I actually have a huge sextant? And this is a model of the observatory. You can actually see up there is a sextant built on the roof. And what you can see in the picture on the right was the arm of the sextant was extending down this pathway. That pathway was, padded with marble. The marble got eroded. I'll show you a picture of it. But if you can actually use this approach, then you can over, a small angle change on the top of the building with the small sextant, but then you have the long wooden arm amplifying that. You should be able to see even subtle differences in the change in position. Okay? So this is what the channel of the arm that went in, and the arm of the sextant was 164 feet, 50 meters. Okay? Again, at the origin of the change of the angle, 1 degree, you're not going to notice it. But at 164 feet away, any small shift, you will notice that as a big difference as the arm moves. Is this concept clear for people? Does it make sense? Okay. So this was his idea, and then he went on with this approach and said, okay, I'm going to take measurements of the sun position. I'm going to take measurements of the moon, the planets, the stars, etc., and develop his own Zij book. And this is why I highlighted Zij Sultani that he wrote. So he wrote the book, and we have plenty of copies surviving of it today, in 1437. And he was able to accurately measure the sun's altitude, very accurately. He was able, the stars and planets' positions, and the duration of the year. When is the exact start and end of a year? When does a star or the sun go back to the same origin point perfectly in the sky? That's not an easy thing. He managed to figure that out. Okay? And then the periods of the planets. And he was able to measure sine values. So if we're talking angles here, 9 decimal places to a degree. So if you're thinking 1 degree, which is minuscule, he was able to go, 0 point, add 9 zeros to the last digit number that he could measure. That's pretty good, given the equipment that they had. And it came from just ingenuity and just being creative, right? A small change at the origin is not noticeable. But 164 feet away is a big difference, right? So, let's take a look at his measurements, okay? So for example, the length of the tropical year, he estimated this is gonna be 365 days, 5 hours, 49 minutes, and 15 seconds, okay? This is the length of a tropical year. Can anybody guess how far off is he? In minutes or hours or seconds? Is he off? He's not off by days, right? We know the years are 365 days. Is he off in hours? No. His hours are pretty accurate. Is he off in minutes? Yeah, seconds. He was off only by 25 seconds. This is, by the way, the 25-second accurate measurement is what we know nowadays with satellites, measuring the position of the sun. So for somebody with a long wooden arm to figure out this measurement, he is pretty accurate. He's pretty good. I think he just needed to make the arm 50 feet longer and he would have been okay. No, but you come to think about that. This is 500 years ago. There were no electronics, no technology, and he managed to arrive at such accurate measurement. By the way, Nicholas Copernicus leveraged this data, tried to generate his own 88. He was 88 years later. He had much more modern equipment, and he still couldn't get his data to be more accurate than 30 seconds in. So he couldn't beat. Ulugh Beg had the most accurate measurement of the year until we had satellites, until space travel. The other thing he measured was the axial tilt, okay? Remember how I said he measured to 9 decimal places of a degree? So the axial tilt, the Earth is tilted on its side a little bit when it comes to its orbit to the sun. And the axial tilt, he measured 23 degrees, 0.5047. Can anybody guess how off is he? How far off is he? So the actual is 23.4392. He was off by, his error was 0.0655 of a degree. So that is still pretty good, right? He figured out the axial tilt very accurately. And again, this was the most accurate measurement until modernity. So in addition to his observatory, moving on from his measurement, in addition to his observatory, he built the Ulugh Beg Madrasa. And the Ulugh Beg Madrasa in Samarkand still stands until today. It's an amazing site to visit. And in that madrasa, they taught medicine, they taught geography, they taught math, and they taught theology, fiqh. Fiqh was a requirement for everybody to study, by the way. And Ulugh Beg himself, in that school, he taught astronomy and mathematics in that school to the people. And we have records from that school. They were teaching heliocentricity, meaning the sun is the center of the solar system, not the moon. Interestingly enough, the Europeans are not going to adopt or start hearing about an heliocentric model until Copernicus comes 800 years later, and they wouldn't believe Copernicus for a couple hundred more years, and then eventually it will catch on, and now it's the theory that everybody goes with, that the sun is the center of the solar system. But for the Muslims, this was established way earlier with their scientific research. And that's my presentation. Any questions?
Do you guys have any questions for Brother Ahmed?
Any questions about anything? You can ask about pre-Islamic astrology, or astronomy, whatever you want to call it. It was more astrology than astronomy. Pre-Islam, you can ask about, anything. Sky's the limit, or actually sky is not the limit for astronomy. Cheesy jokes. The Big Bang Theory itself does not conflict with the Quran at all. No, just, okay.
We have actually
Yeah.
a video on our Facebook page. If you go to NWICC, we had a Dr. Suhaib. He's from Pakistan. He came to Al Amal school and he presented on this. And his specialty, his PhD and everything was on this, and he has books that he's wrote on this. And he did a whole presentation on the different aspects and what would contradict Islam if we were to say something is wrong with the whole beginning theory and how humans evolved, evolution and all the theories. You can go to our Facebook page. It's about 2 hours, but it's very, very informational. So I would highly recommend you watching that.
Yeah. What the Big Bang Theory, just high level, what it says is that in an infinitesimally small amount of space, think of a tip of a needle, there was a large amount of energy inserted into that, and that amount of energy led to that amount of space to expand, and hence the, and as it expanded, and they call it, there was an explosion of energy in that infinitesimal space, hence the name Big Bang. And then you have a significant expansion of that space because of the energy. And then over time, the energy slows down. And as the energy slows down, it forms the very basic component of matter, which is hydrogen. Hydrogen, just one electron, one proton, and one neutron, right? The very basic thing. Now, over time, hydrogens will fuse to form heavier elements with nuclear reactions, so helium and other stuff. But that's what happens with star formation. And that's the gist of the Big Bang Theory. Does it contradict the Quran from the standpoint of khalq and so on? I don't think it does. There's nothing in it that contradicts the Quran.
The only thing I think from an Islamic perspective that would be contradicting the Quran, where atheists and people who are trying to explain everything from a scientific perspective, they don't know what was the cause for everything to start in the Big Bang Theory, right? And that's where they will say, we don't know, it's an unknown. Whereas Muslims will say that's Allah subhanahu wa ta'ala. It's they're not ready to make that jump, but for us, we can easily say there's always a cause, right? Cause and effect, and Allah subhanahu wa ta'ala is the causer of whatever the effect is.
So going back to astrophysics, in astrophysics, the time at the beginning of the Big Bang, that initial time is time zero. And since then time is going forward, time can never go back. We know that as a well-established fact in physics. Time can never go back, it's always going forward. So for those who are thinking there will be a time machine one day, that will never happen. It's a good story, but yeah, we can, there's a lot of theories that hopefully will pan out, but not the time machine.
Yes, go ahead.
Yeah. Well, excellent. No, I'm not saying it does. I'm saying it doesn't contradict Islam. No, I agree, and I totally agree with what you're saying. I was gonna get to something that Sheikh Saifullah was saying. Now, so you have two kinds of people. You have philosophers who are trying to figure out what's before T0, and astrophysicists have decided that we cannot know what's before T0 because that's T0. Okay. Now, there's another aspect of the debate, which is, does the universe start at a specific time and then it goes on and then it decays, right, and dies out? Or does it go in a cyclical pattern? And this comes from the idea that Abrahamic religions, so Hinduism and Buddhism, have that theology that the universe is cyclical, that it will burst. So some people in the 1970s and 60s, including Stephen Hawking, by the way, was of the thought process that, oh yeah, the universe, there was the Big Bang, and then it expands, and then at some point it's going to collapse, and then you end up with a Big Bang, and etc., right? And at that time, I don't know if any of you heard of Kip Thorne. Kip Thorne is the guy who won the Nobel Physics Prize in 2016 for his work on black holes. Kip Thorne and Stephen Hawking had a sort of a bet. Kip Thorne said, no, the universe has a starting moment and an ending moment. It doesn't go to infinity. And it's not cyclical. It's not cyclical. It doesn't go to infinity. It has a beginning and an end. And Stephen Hawking was the guy who said, no, it has no beginning. It has no end. It's cyclical, right? If anything, in Islam, we know that the universe was created, and there will be a day of judgment where it will have an end. Okay, Allah will have we have a beginning and an end to it. The interesting thing is Stephen Hawking, although he took the position of cyclical, his research in the 90s and then by the early 2000s, he ended up arriving at the conclusion that the amount of energy that started with the Big Bang is converting to material, and losing that loss of energy is not recoverable. So eventually everything will just decay. Everything, as Allah says, فَجَعَلْنَاهُ هَبَاءً مَنْثُورًا, everything will literally become pure dust. There will be no more energy. Everything in the universe is headed towards dying and becoming pure dust. So interestingly enough, Stephen Hawking is the one who proved that, and he ended up losing his bet to Kip Thorne. Although he was the one who believed, no, this is cyclical and it will keep on going.
That's actually an ancient position, right? Because many of the ancient philosophers, including so-called Muslim philosophers, such as Ibn Sina, fell into the same debate and came to the conclusion that the universe is eternal and whatnot, and it's continuing. So that was a huge debate as well in the past. But it's very interesting. But see, Muslims talked about this hundreds of thousands of years before everyone else.
No, but Stephen Hawking with collecting data, because we can see the afterglow of the Big Bang, and we've collected data on that, on the energy, and he concluded that energy is non-reversible, where this expansion can lead to a collapse and then another Big Bang. No, it's over. It's a Big Bang is a once in a lifetime for the universe event, and there will be a moment where it becomes just literally, the way he described it was just ash. His data, I forgot how I have a book on it. His data, his conclusion was like, it has to do with the increase of entropy and how entropy is non-reversible. And at some point, you've introduced too much entropy to the system and consumed the energy, and you can never go back. It's over. Yes, that's a different debate, that there is a fourth spatial dimension that exists. We just don't know where it is. We can't. We have signs that it exists, physical signs that it exists. We still haven't figured out where it is. So subhanAllah, when Allah tells us, the malaika around us and jinn and so on, and we don't see him, and some people say, well, if I don't see it, it doesn't exist. Well, guess what? There's a fourth dimension you don't see, and physics has proven it exists. We know it exists, we don't know much about it.
And that's interesting, because I've read some theories on the journey of Al-Isra wal-Mi'raj and how it was possible to journey that far in a short period of time. And the concept is that there is a fourth dimension in which the journey from one corner to another corner is as if you were to fold the paper of two sides together. You no longer have a journey that much distance to cover. So it's interesting. But I was going to say the other thing about the end of the earth and everything. That is very in line with the Quran, right? And the Quranic description of the Day of Judgment, right? Where Allah subhanahu wa ta'ala says, يَوْمَ نَطْوِ السَّمَاءِ, the day that we will fold this heaven up, like the folding of a book. So, and that's how it comes to an end. Wallahu a'lam. But it's interesting, interesting discussion.
Unfortunately, Stephen Hawking died as an atheist. Although his research, if he would have looked at it objectively, should have brought him to Islam. And the reason he died as an atheist is because he thought what happened to him, his illness and being, wheelchair ridden for the rest of his life, was unfair. And he was saying, okay, this is unfair. If there is a God, then that God is unfair from his perspective. So he insisted on atheism, or at least being an agnostic. So.
Any other questions before we wrap up? We have a few minutes until Salah. Any questions? You have a question? Telescopes?
Yeah, I brought two telescopes.
Yeah, inshallah. We will after Maghrib Salah.
And I got a friend of mine coming over with a telescope after Maghrib, inshallah. We'll have him set up,
Yes, there is a surah, from my understanding, which is surah of constellations.
Yeah. There is Surah An-Najm, and Surah An-Najm is one of the most powerful surahs in the Quran, because if you read the entire surah itself, Allah subhanahu wa ta'ala goes, I've mentioned Al-Anwa', which were the Arabs' equivalent of constellations. And Allah subhanahu wa ta'ala in the surah goes against those Anwa' that the Arabs used to use for superstition. The gods that they associated with the planets, Allah goes against that. The different stars, أَنَّهُ هُوَ رَبُّ الشَّعْرَ, the Sirius, the star that people used to worship. Allah's going after all that stuff and saying, none of those are gods. All of those are created. And then the end of the surah ends with a sajda. So you're going to reject all, the surah itself is a command. You're going to reject all of this. You're going to reject all the superstition, and you're going to believe and obey Allah and surrender to Him. And that's one of the most powerful things in the surah itself, that when it was read to Quraysh at the time, even the Prophet ﷺ, when it was revealed.
What's the second strongest surah?
The second strongest surah. Good question.
But
yeah.
By the way, there is this surah, Surah Al-Buruj.
There's Surah Al-Buruj. It's going after the constellations also.
Yeah. So وَالسَّمَاءِ ذَاتِ الْبُرُوجِ, Allah, He takes an oath by the heaven and the constellations, the stars in the heaven, in the sky.
So and going back to Surah An-Najm, when it was revealed, the Prophet ﷺ came out to the public and read it, and at the end of it, فَاسْجُدُوا لِلَّهِ وَاعْبُدُوا, everybody, whether they were Muslim or non-Muslim, made sajda, including Al-Walid ibn al-Mughira, who was so proud. He didn't want to make a sajda, so he grabbed some sand and put it on his forehead, showing respect to the surah. Although he never became a Muslim, and he was a staunch opponent to Islam, but even for him, that surah was very powerful, going against the Arab astrology and their superstition and everything, disassembling it completely, saying that none of those things matter, none of those things mean anything. You guys take them as gods or guidance or whatever. It doesn't mean anything.
Detail as well in the surah, right?
Allah
covers all the detail and covers the names of the gods, like we talked about, by name, right? Allah subhanahu wa ta'ala is addressing each of them. And the Arabs, they already believed in Allah subhanahu wa ta'ala, but they had these other idols and gods that they worship. So Allah subhanahu wa ta'ala is calling them out each by name, and said that in hiya illa asma'un sammaytumuha antum wa aba'ukum, right? That these are just names and just things that you and your forefathers have named and call out. But I think we should end with that.
I got one last point. One very powerful ayah in the Quran relating astronomy to Islam. فَلَا أُقْسِمُ بَمَوَاقِعِ النُّجُومِ وَإِنَّهُ لَقَسَمٌ لَوْ تَعْلَمُونَ عَظِيمٌ. Allah is making an oath with the positions of the stars, that Allah knows the positions of the stars. And it's an oath to the Arabs at the time. If they in the Quran saying, if they were to know what it means, it's a big deal. It's a very powerful thing. Now to them, they're looking and saying, what do you mean by the position of the stars? We see it. There it is, right? We know where it is, right? To them, that's what it meant. Now to us, and you read the old tafsir, where everybody's looking at it and saying, okay, we know from the Quran what we see in front of us is not really the true positions of the stars, because Allah told us so. But they couldn't have the evidence. Now we have the evidence that everything we're seeing out there is in the past. And the farther out it is, the farther it is in the past, and it moved on, and it's not in that place. So positions, or even is it still around, or did it blow up? Did it die, or anything? None of that lines anymore. And so subhanallah. So Jazakallah khairan.
Jazakallah khair everyone for coming. So inshallah after the salah, we will go and we'll try to see some mawaqi' an-nujum, inshallah, some of the positions of the stars, whatever we're able to see. But I think it's a good forecast, right? So we should be able to see some good stuff, inshallah.
It's looking clear.
So for those who want to join us after the salah, inshallah, outside. Jazakallah khair wa sallallahu wa sallam.